Today's lesson is about defining continuity at a single point. So we are looking at functions and deciding if they're continuous at a single point. So three things must be true for continuity to exist at a point. So the function is defined at a point. So let's say f of 2, it has a value, it's defined. The function has a limit at a point. So let's say the limit as x approaches 2 of f of x, let's say the limit is 4. And then that limit value has to equal that function value. So if they are equal, then it is continuous at that point. Okay, so here we're looking at this function f of x. And it says, let f be the function defined above. Verify whether f is continuous at this value at x equals 2. So I have a little checklist here. So at x equals 2, we have to check, does the function value exist at f equals 2? So what is f of 2? So here, f of 2, because this function does not exist at 2, so at x equals 2, the y value is 1. So it does exist. That function value exists. Okay, limit as x approaches 2. So for the limit, we want to look this function if it's approaching 2, looking at the left and the right. Well, first off, if I have x squared minus 4 over x minus 2, if I factor the numerator, that's going to go to x plus 2 x minus 2 over x minus 2, so those cancel. So if I look at the limit as x approaches 2 of x plus 2, that is going to equal 2 plus 2, which is 4. So the limit does exist. It approaches 4, but there is a hole. So to give you that visual, I've got this linear function. There's a hole. So it's approaching. So the limit exists, but the function value is down here. So as you can see, the limit does not equal. So the limit as x approaches 2 does not equal f of 2. So that is false. So therefore, this is not continuous at the point x equals 2. Okay, next example, we're looking at a graph. So is f continuous at x equals 0? So, I mean, it's kind of obvious to just look at this graph, but we still have to kind of follow the steps for practice. Okay, so f of 0. What is f of 0? Looks like it is 1. Okay, what is the limit as x approaches 0? So from the left and the right, it is approaching 1. So exists, and is the limit value equal the function value at that point? That is true. Therefore, it is continuous at that single point. So as you can look over the whole domain, it's not continuous, but all we're doing is looking at continuity at a point today. All right, now look at this example. Same graph, but we're looking at a different point. So at x equals -2. All right, so does f of -2 exist? So f of -2, no, there's a hole there. It does not exist. So right away we can say it's not continuous. So even though the limit exists, this does not, therefore this is false, so this is not continuous. All right, last example. So here's the function f. Verify whether f is continuous at x equals 3. So let's go through the steps. So what is f of 3? Well, it looks like if I'm plugging in 3, I have to use this. So that would equal 3 plus 2 equals 5. Okay, does the limit as x approach 3 of f of x exist? Well, in this case, let's check both sides, left and the right. So limit as x approaches 3 from the left. So from the left, that's using the top function that equals 5. And then limit as x approaches 3 from the right, that's going to use that second function. So of f of x equals, so 4 times 3 is 12, 12 minus 7 is 5. So because the limit exists from the left and the right, the limit does exist, and it equals 5. So function exists, limit exists, and then to write the proper justification, so because f of 3 equals the limit as x approaches 3 of f of x, and they both equal a value 5, therefore f is continuous at x equals 3. So there is your full video on continuity at a point. Good luck with your lesson.